Okay, hi everybody, Mrs. Ondra here. There've been several people who have emailed me and expressed some confusion or concerns over the third assignment where you had to write the equation of a polynomial. So I thought I would just do a couple examples and explain them, and hopefully that will help. So here goes. So let's suppose that I gave you a graph, and no worries, my graphs at home are going to be just as bad as the ones that I would give you at school. So let's say I'm going to graph a polynomial that looks like this. And our goal is to try to write the equation of this polynomial. Okay, so two things. First of all, notice that there's no other points on the graph except for the x-intercepts, right? So since there are no other x-intercepts, there could be a lot of equations that have this graph, right? Because we don't know how high or how low these points go. So all we're looking for is one possible equation, and we'll make it as easy as we can. So we're going to start with our zeros, right? So remember that our real zeros are where the graph crosses the x-axis. So in this case, we have 1, 2, 3 real zeros. So those values are x equals -3, -1, and +2. Okay, if we have our zeros based on what we talked about before, while we were still at school, we said that we should easily be able to identify our factors, right? So if the zeros are -3, -1, and 2, then our factors, remember, are going to be in parentheses, and we know they're going to be the opposite, right? So we'd have x plus 3, x plus 1, and x minus 2. Okay, so then to write our equation, we're simply going to make it a y equals, and we're going to keep that the same. You do not have to factor all that out, or multiply it all out, sorry. So we're going to leave that in factored form. And then the only other thing we want to do, because this value in front here could be anything, right? This number in front is what tells us how high or how low these peaks and valleys go. So it could be anything. And you could put any number you want in there. You could leave it and just assume that that's a 1. Or you could put something else that really makes no difference at all because we have no scale on the y-axis. But the other thing we have to do is think about whether this number in front should be positive or negative. So the fact that our right side goes down always tells us about that leading coefficient, right? Since this right side is going down, what does that tell us about the leading coefficient? That means that the leading coefficient is negative. Okay, remember it's always the right side of the graph that tells us about that leading coefficient. So since the right side is going down, our leading coefficient is going to be negative. So I'm just going to put a -1 in front. And again, you can make it negative anything you want. It makes no difference. And we're just going to leave that in factored form. Okay? Okay, let's try one that is a little bit harder. We're actually going to do 2 more maybe. Let's try this first. So we can talk about multiplicity of roots or double roots, which were in my notes and in that video that I sent you, but it's kind of hard maybe to understand. So let's just say we had these 2 zeros, and let's say our graph looked like this. Okay, so in this case, we could easily identify our zeros first, right? So our zeros are 0 and +2. Okay, but notice that if you look at these 2 points, they look a little bit different, right? When x equals 2, the graph goes right straight through that point. But at x equals 0, the graph just touches the x-axis and goes back in the direction that it came. All right, so this root here is what we just call a single root. Nothing fancy about it, right? It just occurs one time. But this root over here, since it just touches the x-axis and bounces back off, is what we would call a double root. So remember when we talked about a root occurring more than one time, a repeated root? That's exactly what this is. So that just means that x equals 0 really would occur twice in our equation. Okay, so what are our factors going to look like? So since x equals 0, we would have a factor of just x, right? It could be x minus 0, but we don't need that part. Well, if this is a double root, that means that there are 2 of them. And then we would have x minus 2, again, because it's the opposite, right, of that +2. So when we write our equation, if we combine these 2, that just becomes x squared, right? So the square here tells me that it's a double root times x minus 2. And then we just need to think about our leading coefficient. Again, no scale on the y-axis tells me that there could be any number in front here as long as I make sure that it's negative or positive appropriately. So again, which side are we going to look at to determine whether it's positive or negative? We are always going to look at the right-hand side. Since the right side goes down, that tells us that the leading coefficient is negative. So again, does it matter what number I put in front here? As long as it's negative, it makes no difference whatsoever because again, we don't have a scale on the y-axis. Okay? All right, so let's do one more like the third and fourth example that you had on your third assignment. And we'll talk about why this one is a little bit different than the others that we just did. So let me just go ahead and draw some type of graph here for you. You know me and my colors, I like things to be exciting. So let's say that I have a point here, here, and here. And let's suppose that my graph is going to look like this. Okay, and let's also suppose that I know this point here. Okay, so what's different about this graph? The only thing that's different is that even though I didn't draw a scale on the y-axis, notice that we have another point here, right? That point does give us an actual scale on the y-axis, even though we didn't label it. So that means we should be able to find that exact coefficient instead of just putting any number in front. So we're still going to start the same as we did before. So we have zeros at -1. We have a 0 at 0. And then we have a 0 at +2. Okay, so now let's go ahead and write our factors. So if -1 is a 0, we have a factor of x plus 1. If 0 is a 0, then we have a factor of x. And if 2 is a 0, then we have a factor of x minus 2. Anything special about any of those? So again, let's take a look at our zeros. Straight through the x-axis, so it's just a single root. Straight through the x-axis, so it's a single root. What happens here bounces off the x-axis. So what do we know about this one? This one is a double root. So that means, what is that x value? That's 2. So that means that this factor, x minus 2, should be a square factor. Okay, so now let's write our equation. So y equals, I'm just going to move that x to the front because my brain likes that better, but it really makes no difference. Okay, now, what do we know about the leading coefficient? Well, we know the right side is going up, so the leading coefficient has to be positive, right? Okay, but since we have this point at 1, 3, we should be able to figure out what this exact coefficient is. So for the time being, I'm going to call it A. How are we going to find that value of A? Good question, right? Well, in order to find that value of A, we have an x value and we have a y value, right? So let's take that point and we can substitute in to our equation for x and y, and that'll allow us to solve for A. Now, if this were going down, you don't have to worry about whether that leading coefficient is positive or negative. It's going to work itself out when you actually do the math. So just leave this always as just A, and if it turns out to be negative, it should turn out to be negative, right? So don't worry about that. Okay, so I'm going to plug 3 in for y and 1 in for all of my x's. All right, now let's just simplify this. So 1 plus 1 is 2. 1 minus 2 is -1. And then if we square -1, that's going to become a +1. All right, now multiply these 3 together. So 1 times 2 times 2 is 2. So that just becomes 2 times A. And then we're going to, whoops, I didn't mean to do that. We're going to divide both sides by 2. So A is 3/2. And A is generally going to turn out to be some fraction, but who cares? Because we're not doing anything with it, right? All we're going to do is take that value of A and substitute it back in here when we write our final answer. So our final answer then is just going to be y equals A, which is 3/2, times x plus 1 times x minus 2 squared. And there you have it. Okay, and again, we're going to leave it in factored form. So hopefully that helps a little bit. If you're still having trouble, send me an email and let me know, and I will help you the best I can. All right, take care, everybody.